Hello everyone, welcome to the course on computer-aided drug design. We will continue on the topic of QSAR. Today we will look at a couple of softwares which can give us certain descriptors, even the structures. In fact, there are many softwares in the net which free of charge. Web servers are there from where we can get thousands of descriptors. I'm going to show you a couple of them and you guys can explore further. One of them is called a ChemDes. Okay, this is an integrated web-based platform for molecular descriptor and fingerprint computation. It's called ChemDes. Let's have a look at that. Okay, this is the ChemDes. Okay, as you can see, this is the address of this. It's got a lot of descriptors. Look at this descriptors library. See, look at this. ChemDes. It can calculate 787 descriptors. Okay, there is another software is there. There's so many different softwares there, okay, which can calculate. This software can calculate 103 descriptors. This can 196 descriptors, 787. So there are many softwares, PayDel and so on. Okay, let's look at ChemDes. Okay, as I said. ChemDes can calculate almost 1135 descriptors. There are 0-dimensional descriptors, 1-dimensional descriptors, 2-dimensional descriptors, 3-dimensional descriptors, and as you can see, the next column. Okay, these are the descriptors calculated by each of these softwares shown in this picture above. Okay, ChemOPY, ChemDes, and so on. And the details of these descriptors, if you go here, it gives you all the details. Okay, so we can get the details here. Okay, so it can calculate a lot of descriptors here. Okay. It's called constitutional descriptors, connectivity descriptors, basal descriptors, PSAD, so topology, kappa descriptors, so on, so on, so on, so on. And each one there are so many numbers. This is the number here, and if you look here, it gives you the details of these descriptors. Okay, so if you want to go into more details, we can click on them. It will tell you, for example, topology descriptors. Okay, a lot of topology parameters are there. Okay, a lot of topology descriptors are there. Okay, so we can upload a file. For example, we can upload a SDF file. Choose file. I have, I think, aspirin or something somewhere stored. Yeah, I have aspirin. I can get that. Aspirin, then we can do either 1D, 2D or 3D descriptor, 1D, 2D submit. So it will do some calculations and then give the details about that particular. Yeah, so as you can see, it's giving descriptors. Large number of descriptors. Aspirin is there, so I can do a 3D descriptor calculation also. Submit. Okay, so it's given some 3D information about the descriptor molecule. See, as you can see. So you want to get more, you can download this as CSV file and then save it for further calculation. You want to know more about the details of what each descriptor means. I did show you how to find out, right? We can also give the smile notation of the molecule also. For example, CC. Like that, you know. This is a smile notation. Then I can do a submit. Okay, again it calculates the descriptors for that molecule. So this is a CH2, CH double bond, CH, CH2OH. Okay, this is an alcohol with a unsaturated alcohol. Okay, butanol, unsaturated butanol. Okay, so this is a very nice software. Okay, so the descriptors library, as I showed you, it can show you a lot of descriptors. It can calculate. Okay, and as I said, there are, apart from ChemDes, which can calculate 1135, we also have other softwares like okay, Blue Des and Paddle and RD Kit. Each of them can calculate some amount of descriptors. So you have a huge number of descriptor calculation softwares which are free for you. Okay, so you don't need to pay at all. Okay, remember, you don't need to pay at all. We can get a lot of descriptor calculated. Okay, using softwares. Okay, similarly. We also have the Swiss ADME. If you remember Swiss ADME, we have seen that many times. That also can calculate a few descriptors for you. Okay. Okay, Swiss ADME can calculate a lot of descriptors. So you remember this software? I think many times I have shown you this. So we can draw this, then we can do this, then we can say run. But the number of descriptors it calculates are very limited. So if you see log S, solubility, that sort of thing, actually not many retractable bonds and things like that. But if you want to do a real QSAR, ChemDes is a better option, or we can go to the eDragon. Okay, and eDragon calculates 2000 plus descriptors. Okay, for a QSAR. Swiss ADME use only important parameters like solubility, log P, and bioavailability, and so on. But if you are interested in QSAR, you want large number of descriptors, then ideally you should go to this eDragon. It's developed by Milano Chemometrics by Professor Torricini. It's a huge number of descriptors. So you can do it online. Look at this. Okay, so welcome to eDragon. This is the thing. It's got so many descriptors. Okay, thousands and thousands and thousands. Look at this huge number of descriptors, numbers, list of molecular descriptors. It says. Okay, now how do we run molecules? It's quite simple. We can upload data. We need to upload SDF file. SDF file. You can get it downloaded from, if you remember, your Zinc database. Zinc database gives you SDF file, right? Sorry. Yeah. Let's look into. Again, we can run. Yeah. I can do aspirin, open, it's been loaded. So we say upload file. Okay, so the file has been uploaded, we close this, so aspirin has been loaded, then we say submit your task. Okay, so it will calculate all these descriptors. So it's doing calculations. Okay, so it's doing the calculations, goes to the server and does it. Okay, so downloaded, it's done. Okay, so what do? We go here, we say results as text. Okay, so we can see the results here. Okay, yeah, so this is your input file, as you can see, for aspirin. Okay, this is input file for aspirin. Okay, so results have come. So control X, control A, control C, I copied the entire result. Then I can go to Excel, for example, and then I can say control V. Okay, so all your results have come. So this is your molecule. Okay, okay, so you can see this molecule. We can convert this text data to numbers in columns. Yeah, basically we converted that into text to columns. Okay, so it's easy for us to view. Okay, so as you can see, it's very nice to view now. Okay, so molecular weight is 179. Number of carbon, number of nitrogens, and so on. Okay, aspirin, this is. It also gives you some log PS values. Okay, finally log solubility also. So a lot of descriptors you can calculate. Okay, so what's the use of this? Imagine I want to do one more, and so on. Now I want to upload another file, say. Okay, we looked at aspirin. We can look at another molecule, for example. Okay. It's called a zinc. It's called zinc 53. Let's see what is that zinc 53. I don't remember that. Let's look at the zinc 6694. Okay, zinc 6694. Yeah, this is a coxib. This is a yeah. This is selective cyclooxygenase inhibitor. Okay, this is coxib. Okay. As you can see, it's got a sulfur, 2 oxygens here. This is selective cyclooxygenase COX2, selective cyclooxygenase 2 inhibitor actually. So we will load that one. Upload data. Browse. Open. Upload file. Yeah, file has been uploaded. Now submit your task. So it started this task. Results as text. Okay, open results in a browser. Yeah. So Control X, Control A, Control C, and then go. So we can convert data into text to column. Okay, fixed width, delimited width, next, space, next. So 314 it says, right? So this is a coxib, which is a selective cyclooxygenase 2 inhibitor. We can remove this column also. So okay, so this is another molecule. Okay, there's a different molecular weight and so on. So it goes with the descriptors. So if I know the activity, that is my Y for my QSAR, and these are the X's. Okay, if I have many molecules like this, activities are known, I can develop a regression relationship with the one descriptor model or two descriptor model depending upon the number of data. You understood? So Dragon is also a very powerful software for getting a large number of descriptors. Okay, the details of the descriptors we can get it as I said we can get the details of the descriptors from it. Okay, details of descriptors we can get it from the main page of the software. Okay, so well, like I said, if I have the activity details, that will be my Y, my regression relation. I can select the best descriptor and then develop a regression relation. Y is equal to say mx plus c type. X could be my okay, one of the descriptors. So depending upon the number of data points, I can have one descriptor model or two descriptor model or any descriptor model. Okay, so we talked about Dragon, then I showed you the other software, ChemDes, that also calculate descriptors. Okay, huge number of softwares there. Okay, so you don't need any commercial software. As you can see, so many different softwares there which can calculate descriptors for you. Okay, so we have imagine some activity, we have some descriptors. Okay, so how do you go about doing this business of calculating the regression relation? The simple, if it's a simple model, then we can, it's not very difficult for us to do. We can use Excel, for example. Okay, so I can say molecular volume Molecular volume, as you can see, 420, 332, 198, 467, 359. Okay, then activity could be 2.34, 1.89, 0.23, 3.67, 2.55. okay, log P 2.8, 4.6, minus 0.3, 3.7, minus 1.5. It's quite hydrophilic. Then your dipole 0.97, 2.23, 3.38, 0.45, 1.77. okay, now we have only 5 data points, so at the most we can develop only one independent variable regression relationship, either with molecular volume or log P or dipole only. So how do I find out? I can use a correlation to see whether there is a correlation between the X, this is the X, and the activity. Let me see what is it. Oh, it's quite good. Molecular volume, it shows quite good correlation. Let's see whether log P also has a correlation. Not so good. Let's see dipole, how good the dipole has a correlation. Okay, so this also has a very good correlation, negative. That means as the dipole increases, activity decreases. Now molecular volume is positive, so as the molecular volume increases, activity also increases. Okay, now let's draw graph also. We can insert scatter. Okay, so we get a scatter plot. As you can see, as the molecular volume increases, your activity also increases. This is molecular volume on the x-axis, activity E. So we can draw a trend line. I think you all guys must be good at Excel. Okay, display equation, display R square value, close. Okay, so this is your QSAR. Activity is equal to 0.0117 into molecular volume minus 2.025. R square is pretty good. Equal to 0.92, which is very nice. Let's do with the dipole also, because dipole also is good. So we may have a QSAR with the dipole also. So let's look at dipole. X is equal to dipole. Y is okay. Okay, so as the dipole increases, activity decreases. Like I showed you, it's a negative correlation here. And if you look at the R square here, R square, this is also good. So this is a QSAR with respect to dipole. X is equal to minus 1.03 because it's going down, into dipole plus the 3.9. Here molecular volume regression is activity is equal to 0.0117, molecular volume minus 2.254. So we can have either one of the QSARs. R square here is 0.92, R square here is a little bit less. That doesn't matter, it's not so greatly bad. So we can have, depending upon what we feel like. Whereas if you plot the log P, the correlation is very poor, 0.38 only. So we will not go for this type. So Excel is a good software if you are interested in looking at regression equation with one independent variable model, okay, with one independent, so we can work out with Excel. That's not a big deal. So we can have a molecular volume or like I showed you dipole, or we can have multiple linear regression, but then multiple linear regression is not possible because the number of data points is only 5. General rule of thumb is if you have 5 data points, go with only one descriptor model, don't go for more. If you have 10, maybe. So this generally is not a good idea, okay. Or we can have partial least square, a lot of statistical terms come in actually, okay. So this is how we go about doing simple structure activity relation, mathematical relation. Okay, so what do? We need to build models, calculate minimum energy conformation if you are looking at minimum structural features, then calculate descriptors. I showed you some softwares, you may be able to find more softwares. Then you need to shortlist descriptors. You cannot take like in Dragon there are almost 2000 descriptors. We cannot take all of them, so we need to, based on the correlation coefficient, like I showed you here, right? The Excel, the correlation coefficient for molecular volume is very good, dipole is next good, so I may go with molecular volume. So this is what it means: shortlist descriptors based on correlation coefficient. These descriptors should not be cross correlated. That's another important thing. Okay, so what does that mean? There should not be a correlation between this and this, or this and this. Let's look at whether there is a correlation between this and this. Maybe there is. Let's see. Then we cannot use the same descriptors. This is molecular volume and wow. Okay, molecular volume and dipole has very high correlation. Okay, so obviously if you are thinking of a two descriptor model, we cannot use both. They are cross correlated. You understand? Two descriptor model. You have to first check that there is no correlation between x's. X's means independent variables. Understand? You can see minus 0.99 molecular volume and dipole. Whereas if you look at molecular volume and log p, I don't think they will be correlated. But of course we are not going to take log p here because the correlation of log p with the activity is quite low. But definitely we will not take this and this because they are both correlated. Okay, so that's a very important point. They should not be correlated. They should be dissimilar, as dissimilar as possible. So we can do cluster analysis, we can do so many things to shortlist descriptors. Shortlisting descriptors is a big challenge. So because you have 2000 descriptors and I may have only 10 data points, so I need to select 2 descriptors out of this, so I may make a mistake. I may not select the right descriptor, I may miss out descriptors. So that's the biggest challenge in QSAR. That's the most biggest challenge in QSAR. How to select the correct descriptor, how to not select the wrong descriptors, how to not select descriptors which are correlated with each other. So all these you need to consider, and there are many approaches. Once we do that, we develop a regression relation. It could be a one parameter regression. If you have one descriptor y equal to mx plus c, if it is 2 parameter y equal to m1 x1 plus m2 x2 plus c, and then you do a lot of statistics. There are something called R square, adjusted R square, predicted R square, F test, residual, so many things are there. Okay. Then when you have a large number of data, you don't use all of them for calculating regression. You divide the data into 2 types: training set, test set. So what you do, you use the training to develop the descriptor and the regression, and then with that regression you try to predict the values from the test set. Okay, so if I have say 6 data points, what will I do? I will take only 5 data points and develop my regression and then try to predict for the 6th one and see how good the prediction is. That's called a test set. Okay, so if I have say 7 or 8, I may take 5 or 6 in the training set, the remaining 2 will be in the test set. Generally they say 20% should be in the test set, 80% of the data in the training set. So if you have large number of data, you just don't develop regression with all the data points, you follow the 80-20, 20% for test set, 80% for training set. So you train your model and calculate the various terminology, various terms like M and C, with 80% of the data, and then you predict the remaining 20% of the data using that model to see how good the prediction is. Okay, that's very, very important. Okay. Then you can also test with external data. You make experiments, get some results activity, and then see whether. So you need to do all these to be sure that your model is good and it has got good predictive capability. That's very, very important. So the descriptors like topology, electronic, thermodynamics, structural, all these are descriptors which I showed you using different web servers which are free for you to use. Okay. So we need to have at least 5 data points for a regression equation with one descriptor model. And when you have a data set, don't use all of them for training and developing the model. Use only 80% of them for training, and remaining 20% use as testing out the test set. Okay, so it's very, very important that you have a training and a test set 80-20, and your model should be able to predict the results of the test set, whereas you use the 80% of the data for developing a regression relation. Without test set, a regression, a QSAR is of no use. It's very, very important that you also have a test set. Okay, we will continue more on this QSAR in the next class as well. Thank you very much for your time.